4 light years from Earth, the James Webb Space Telescope just changed everything. It may have found a Saturn-sized planet orbiting Alpha Centauri A, the star closest to our own Sun. But this is not just another exoplanet. Sometimes the planet simply vanishes from Webb's gaze, defying every expectation and raising a shocking cosmic question. Astronomers are confronting one of the strangest disappearances in nearby space, and what they uncover will challenge what we think we know about planets, stars, and our place in the galaxy. So why is the nearest solar twin hiding such a mysterious world? Among the hundreds of billions of stars in our galaxy, only a handful share the Sun's rare combination of mass, temperature, and age. Alpha Centauri A stands out as the nearest of these so-called solar twins, shining just 4.37 light-years away. With a mass about 1.1 times that of the Sun and a surface temperature close to 5,800 Kelvin, this G2V main sequence star has long captured the curiosity of astronomers searching for worlds like our own. Its luminosity is roughly 1.5 times greater than the Sun's, making it the brightest member of the Alpha Centauri system. The age of Alpha Centauri A is estimated at over 4.8 billion years, placing it in the same evolutionary phase as our Sun. This combination of similarity and proximity has made Alpha Centauri A the most scrutinized target outside our solar system. Yet, even with its familiar qualities, the search for planets around this star has proven elusive, as astronomers have struggled to separate any faint companions from its overwhelming glare. Still, the possibility of a planetary system so near, circling a star so much like our own, remains one of the most compelling prospects in the search for life beyond Earth. Alpha Centauri A and B orbit each other in a slow, elliptical dance, completing one circuit every 80 years. At their closest, just 11 astronomical units apart, the two stars approach the distance between Saturn and the Sun. At their widest, they drift out to 36 AU, nearly as far as Neptune's orbit. This shifting separation turns the region around Alpha Centauri A into a gravitational minefield for any forming planet. The binary companion's pull stirs up the protoplanetary disk, increasing collision speeds among planetesimals and making the gentle assembly of worlds far more difficult than in our own solar system. Even for astronomers, the glare from Alpha Centauri A and the nearby B component creates a wall of light. Any planet reflecting or emitting its own faint glow is buried under a brightness difference of more than 10,000 to 1. Standard telescopes and imaging techniques are overwhelmed, unable to resolve such extreme contrast or filter out the constant interference from two luminous stars. For decades, this combination of binary chaos and blinding glare has kept Alpha Centauri's potential planets hidden, setting a technical barrier that only the most advanced instruments could hope to overcome. August 2024 brought a turning point in the search for planets beyond our solar system. Webb's mid-infrared instrument, using a 4-quadrant phase mask coronagraph at 15.5 microns, captured the faint glow of a Saturn-sized world orbiting Alpha Centauri A. The planet's signal was more than 10,000 times dimmer than the star itself, buried deep within a sea of scattered light and instrumental noise. At a projected distance of about 2 astronomical units from its star, the planet stood out as a subtle but persistent point of infrared emission. Charles Beischmann, leading the observing team, described the custom sequence as tailored for a challenge only Webb could meet. The detection was not just a technical feat, it was a testament to the telescope's ability to reveal what had eluded astronomers for decades. For the first time, Direct evidence pointed to a gas giant circling our closest solar twin, setting the stage for questions no one had yet answered. February and April 2025 brought a puzzle that left astronomers searching for answers. The planet's signature, so clear in August, was now missing, even though Webb's instruments repeated the same sensitive search. For months, the data showed only the star's infrared glow, with no sign of the Saturn mass world. Aniket Sanghi at Caltech set out to resolve the paradox, running millions of orbital simulations that combined every detection and blank. His models revealed a hidden pattern. In over half of stable scenarios, the planet's elongated orbit would carry it too close to Alpha Centauri A for Webb to separate its faint heat from the star's blinding light. The best-fitting paths traced ellipses between 1 and 2 astronomical units, matching an earlier 2019 ESO sighting. The planet hadn't vanished. It was simply lost in the glare, its presence masked by the geometry of its orbit and the limits of even the most advanced telescope. A planet tracing an elongated path between 1 and 2 astronomical units from Alpha Centauri A faces a world in constant flux. In this binary system, the gravitational pull from Alpha Centauri B stirs the protoplanetary disk, making the gentle assembly of planets an unlikely outcome. Yet the presence of a Saturn mass world here challenges long-standing assumptions about where planets can form and survive. Such a gas giant, with its broad orbit, hints at a disk that managed to remain stable long enough for large bodies to take shape. The planet's size and distance suggest it may not be alone. Large moons could orbit within its gravitational reach, raising the possibility of habitable environments shielded from the chaos of the binary. For scientists, this discovery offers a rare chance to study how planet formation adapts under the disruptive influence of 2 suns, and to ask whether such systems could nurture life in places we've only begun to imagine. Upcoming observation windows are already secured for Webb in 2026, targeting the predicted return of the planet to a detectable position in its orbit. Engineers are refining coronagraph settings to push sensitivity even further, while astronomers prepare to coordinate with the Nancy Grace Roman Space Telescope after its launch in 2027. Roman's advanced coronagraph and wide-field imager will join Webb in a joint campaign, offering new ways to probe the Alpha Centauri system in both visible and infrared light. The combined power of these next-generation observatories is expected to reveal not only the elusive planet's full orbit, but also any hidden companions or debris disks, turning our closest stellar neighbor into the best-studied exoplanet system beyond the Sun. In August 2024, Webb's MIRI coronagraph captured direct evidence of a Saturn mass planet orbiting Alpha Centauri A, our Sun's closest stellar twin, just 4.37 light-years away. This detection, of an object more than 10,000 times fainter than its host star, marked a technical breakthrough, confirmed by Charles Baishman's team. Yet, subsequent blank frames in February and April 2025 raised new questions. Aniket Sanghi's orbital simulations, paired with the European Southern Observatory's 2019 hints, revealed a likely eccentric path that explains the planet's apparent disappearances. Still, the planet's exact orbit, atmospheric makeup, and potential for hosting moons remain unconfirmed. As of 2026, Webb and the Nancy Grace Roman Telescope are scheduled for follow-up observations, aiming to verify these findings and search for possible habitable satellites. For the first time, astronomers have direct, peer-reviewed evidence of a gas giant in the habitable zone of the nearest solar twin. The search for life beyond our solar system now moves closer than ever before, guided by new data but still driven by unanswered questions.